Hey there, universe nerds. Every star you see in the night sky has a story. Like people, stars are born, they live, and eventually they die. But unlike people, their lives can last billions of years, and their deaths can be spectacular enough to outshine entire galaxies. Today, let's trace the entire life cycle of a star, from its humble beginnings in a cloud of gas and dust to its grand finale as a white dwarf, neutron star, or black hole. The story begins in stellar nurseries, giant molecular clouds made of hydrogen gas and dust. Gravity pulls clumps of this material together, and as the clumps grow denser, they heat up. Eventually, a protostar forms, a hot, dense ball that isn't yet a star, but is well on its way. If it gathers enough mass, temperatures in the core reach millions of degrees, and nuclear fusion ignites. That's the true birth of a star. Once fusion begins, the star enters the main sequence phase, the longest and most stable period of its life. Here, hydrogen atoms fuse into helium, releasing energy that balances the inward pull of gravity. Our Sun is in this phase right now and will stay here for about 10 billion years. Main sequence stars can shine steadily for billions of years, creating the stable environments that allow planets and life to exist around them. Eventually, though, the hydrogen fuel in the core runs out. For a star like the Sun, the core contracts and heats up while the outer layers expand. The star becomes a red giant, enormous and bright, but cooler at the surface. In this phase, helium fusion begins, creating carbon and oxygen in the core. For larger stars, the process continues with heavier elements stacking like an onion: carbon, neon, oxygen, silicon, until finally iron forms. Iron is the dead end. Fusion of iron doesn't release energy, so once enough iron builds up, the core collapses. In massive stars, this collapse triggers a supernova explosion, a cataclysm so bright it can be seen across galaxies. The outer layers blast into space, enriching the cosmos with heavy elements, while the core is crushed into something even stranger. For stars like our Sun, the ending is quieter. After the red giant phase, they shed their outer layers into glowing shells called planetary nebulae, leaving behind a dense core called a white dwarf. White dwarfs are incredibly dense. A teaspoon would weigh tons, but they're no longer active stars, just cooling embers that will eventually fade to black dwarfs over trillions of years. For more massive stars, the supernova leaves behind either a neutron star or a black hole. Neutron stars are city-sized objects made almost entirely of neutrons, spinning rapidly and sometimes flashing beams of light as pulsars. Black holes are even more extreme, regions where gravity is so strong that not even light can escape. These are the most dramatic fates a star can have, born from the most massive giants. The life cycle of stars is more than just a story of beginnings and endings. It's the engine of cosmic evolution. Every atom of carbon in your body, every bit of oxygen you breathe, every trace of iron in your blood was forged inside a star and spread into space by its death. Without stellar life cycles, planets and people would not exist. Stars are not just distant lights, they are ancestors, the original creators of the elements of life. So, the next time you look at the night sky, remember, every star is living its own story. Some are just being born in hidden nebulae, Others are shining steadily in their prime. Some are swelling into giants, and others have already died, leaving behind mysterious remnants. Stars don't just light the sky, they light the path of existence itself, showing us how the universe creates, transforms, and continues the cycle of life.